Okay, so blockchain. You've heard the word everywhere, right? It's thrown around in finance, in tech, pretty much all over the place. But what does it actually mean? It feels like one of those things everyone talks about, but hardly anyone really gets. Well, today we're going to change that. We're going to cut through all the jargon, get past the buzzwords, and really dig into what makes this technology tick. All right, so here's our game plan. We'll kick things off with what a blockchain even is. Then we'll do a quick history lesson. After that, we'll get into why it even matters, the big advantages. Then we'll look at how it's used, and finally, we'll help you navigate the wild world of all the different blockchains out there today. Let's do it. Okay, first things first. What is a blockchain? To really get to the core idea here, we need to talk about the problem it was actually built to solve. And honestly, it's a problem that's been around for, well, forever. So think about this. How do you trust a total stranger online? Especially when there's no one in the middle, like a bank or a credit card company, to make sure everything's legit. I mean, that's the big question, right? For pretty much all of history, our solution has been to rely on those middlemen to verify everything. But what if you didn't need one? What if you could create trust between two people who've never met? That is exactly the puzzle blockchain was designed to solve. So here's the textbook definition. And yeah, it sounds a little intimidating with words like distributed digital ledger and cryptography. But don't worry about all that. Let's just break it down. Think of a blockchain as a digital notebook. The big difference is that this isn't a notebook that one person owns. Nope. A copy of this notebook is shared with thousands of computers all around the world. And that simple idea of sharing it everywhere is what makes it so incredibly secure and open. So how does it all come together? It's actually a really elegant three-step dance. First, a bunch of transactions, say people sending money to each other, get bundled up together into what's called a block. You can think of it like a new page for our notebook. Then, this new page is broadcast to the whole network of computers, and they all check the work to make sure every single transaction is valid. And once they all agree, that block gets added to the chain, forever linked to the one that came before it. That's it. Now, this right here is the secret sauce. This is what people mean when they say blockchain is immutable. Because every block is mathematically locked to the one before it, you can't just go back and change something. I mean, you literally can't. To change a tiny detail in an old block, you would have to redo all the work for every single block that came after it. And that is a computationally massive, practically impossible task. It makes the record of what happened permanent. It's like setting history in digital concrete. All right, so where did this wild idea even come from? Believe it or not, it didn't just pop out of nowhere with Bitcoin back in 2008. Nah, the roots of this thing go way back, all the way into the world of cryptography and a really interesting group of people called the cypherpunks. Yeah, this timeline really tells the story. You can see it starts all the way back in 1991. Two cryptographers came up with the basic idea of a secured chain of blocks, really just as a way to timestamp digital files so nobody could fake the dates. This was exactly the kind of thing the cypherpunks were into, using math to build a more private world. Fast forward to 2008, the mysterious figure Satoshi Nakamoto puts all the pieces together in the famous Bitcoin white paper. In 2009, Bitcoin goes live. And then the next game changer was 2015, when Ethereum launched and introduced smart contracts, which, well, that basically turned the blockchain into a worldwide programmable computer. And check this out. This message is literally baked into the very first block of Bitcoin ever created, what they call the Genesis block. It's a headline from a London newspaper. And think about the timing. January 2009, right in the middle of the global financial crisis. This wasn't just a random piece of text. It was a statement. It was a timestamp for sure, but it was also a political message about why this new system was even needed in the first place. A direct shot at the old way of doing things. Okay, so now we know what it is and a little bit about where it came from. But so what? Why does any of this matter? Let's talk about the three big ideas, the core advantages, that make this technology so potentially powerful. First up, and this is maybe the most important one, decentralization. It just means there's no single person or company in charge. Because that digital notebook we talked about is stored on thousands of computers, no single government or bank or CEO controls it. You can't hack it by attacking one server, and you can't censor it by leaning on one company. It's incredibly tough. Next, you have security. This comes from two things. One is the crazy strong cryptography. That's just the math that locks everything down. And two is the fact that the entire network has to agree on what's true. This combination makes it unbelievably difficult to cheat the system or create fake transactions. The security is just built right into its DNA. And finally, immutability. Remember that digital concrete? Once a transaction is on the chain, it's there for good. You can't change it, you can't delete it, it is permanent. What this gives you is a perfect, trustworthy record of everything that's ever happened on the network that anyone can go and check. All right, it's super important to get this next part. While this whole thing kicked off with Bitcoin and digital money, the technology itself can be used for so much more. The ideas we just talked about, decentralization, security, immutability, are now being looked at by all sorts of industries. And just to give you an idea of the scale we're talking about, look at that number, $1.76 trillion. That's the amount of value that a firm like PwC estimates blockchain could add to the global economy by the year 2030. This isn't just a niche hobby anymore. We're talking about a serious economic shift. And you can see the potential in so many different areas. I mean, take supply chain. Walmart actually uses a blockchain to track food. If there's a safety issue, they can pinpoint the source in literally seconds instead of the days or weeks it used to take. Or think about healthcare. Imagine if you controlled your own medical records and could grant temporary access to a doctor. Or gaming, where you could truly own your digital items. The list just goes on and on. Okay, so this brings us right up to the present day. And here's something you need to know. It's not really accurate to say the blockchain anymore. We're now living in a multi-chain universe. It's this massive, sprawling ecosystem with hundreds of different blockchains all running at once. So let's try and make a little sense of that map. So why do we have so many of these things? It really boils down to something called the scalability problem. And the analogy here is perfect. Think of a popular blockchain like Ethereum as a highway. What happens when that highway, built for a few thousand cars, suddenly has a million trying to get on it? Total gridlock. That's exactly what happened during the big NFT boom. The network got clogged, things slowed way down, and the fees to make a transaction just skyrocketed, sometimes costing hundreds of dollars. It just wasn't working. So the community came up with two main solutions. You can think of it as building more roads. The first approach is called Layer 1s. These are brand new blockchains, built from the ground up to be faster and cheaper. Think of them as totally new, independent superhighways. The other approach is Layer 2s. These are more like express lanes built on top of an existing highway like Ethereum. They take a bunch of traffic off the main road, process it super fast and cheap, and then just report the final results back. Now, in this multi-chain world, you'll also hear about two different kinds of networks, mainnet and testnet. It's pretty simple. Mainnet is the real thing. It's live. Transactions use real money, and everything you do is permanent. Testnet, on the other hand, is like a practice arena. It's an exact replica of the main network, but all the money is fake. It's a risk-free sandbox where developers can build and test stuff without worrying about losing real funds. So you might be wondering, with all these different networks, how does your crypto wallet know which one to connect to? Well, that's where the chain ID comes in. It's just a unique number that acts like an address for each specific blockchain. Ethereum mainnet is 1, a particular testnet might be 111551111, and so on. It's just a simple way to make sure your wallet is pointed to the right highway and you don't accidentally try to spend real money on a test network. So when you step back, you can see how far this has all come. From a niche idea for digital cash to this sprawling universe of networks with incredible potential. But that leaves us with one big question, right? As this technology goes more mainstream and as big banks and corporations start to embrace it, can it hold on to its original promise? Can a technology that was designed to be decentralized keep that revolutionary spirit alive? That's the real question, and I guess only time will tell. Thanks for joining me for this explainer.